All right, welcome back. This is lecture 5. This will be the fourth lecture of demand theory and final one for our summer session. Um, Looking back on it now, truly I could have labeled these lectures demand theory 1, 2, 3, and 4, but nonetheless, here we are. So today we're going to cap off the last things that we need to know about consumer theory and the demand side of things. And when I was making the lesson plan for today's lecture, I thought that it might be helpful to take a second to take a step back and get the big picture view of what we're doing. Because one of the things you might have noticed, one of the most striking differences between this class and your principles of micro class, that the very first principles, the very first microeconomics class that you took, is that we have seen little to no demand functions, right? We've seen no quantity demanded, um, equals something something function of price, right? The reason for this is because primarily we want to get a deeper understanding of things. All right. As I've mentioned in past lectures, the stuff that you see in Principles of Micro when you take your first econ class is kind of a collection of facts that they give to you, and they tell you to just tell me the conclusions from what we see on the graph, what we see on the table, so on and so forth. Whereas here, the goal of this class is to build up the foundation for where do these things come from, all right? And this is something I've said in past lectures already. But what I really want to emphasize is first with this class, the first thing we want to do, the first thing we're going to do and we have been doing is building up the demand side of things, all right? And then we will build up the supply side of things. We will talk about firms and why do the supply curves look in the way they do. And then we will bring them together and we will get the classic canonical supply demand graphs. All right. Um, the difference here, as opposed to these supply demand graphs that we saw in our principles of micro class, is that now, after taking this class, you will have a much, much deeper understanding of just exactly where do these curves come from and why do they look the way they do. All right. Because if we think about it, the world is a complicated place, right? And simple graphs especially simple graphs of just straight lines, right? If my demand function is just a straight downward sloping function, this is a bit simpler than how things work in real life, right? And this is kind of by design. We don't want to accommodate, we don't want to try and tackle all of these complexities of real life right out the gate. We need just this framework first, okay? And then once we get this framework down, then we can go and add more complicated nuance to things. All right. One of the things that, as a preview, one of the things that we remember from our principles class was that like we would have our demand curve, our supply curve, and of course we have equilibrium. All right. And this would give us, if we had price here and quantity here, then we have a Q star and a P star. All right. This is pretty much what you saw in your first principle in your first micro class. And then we would have something like this is the consumer surplus and this is the producer surplus. Right? Some subtleties there. I know it just disappeared, but some subtleties there is that, well, one thing you might notice is that, well, if this is the demand curve and this is the supply curve, we'd get something like this, and we have this type of consumer surplus. But what if the demand curve was very flat right here, supply curve was very steep, we'd get an equilibrium like this, and we see that consumer surplus is much smaller. All right. What I'm trying to get at here is that these small subtleties in the mathematics, right? The slope of this demand curve and the slope of this supply curve will affect the conclusions from these models, right? Because if the demand curve is relatively flatter, like on the right side, then we see that the consumer surplus is a bit smaller. So maybe if we were to impose, it went away now, but we recall that if there were price ceilings and price floors or all these interventions in the market, that this can change the surplus. We can shift some of the surplus away from the producer and give it to the consumer, or vice versa. If we thought that this business, the firms in whatever market we're talking about, needed some extra help. All right. What I'm getting at here is that these very small, subtle things in the mathematics of all of these economics, of all these economic equations, are meant to depict reality. All right. And I have a little blurb here. All right. But what the text on the screen says is essentially what I just told you. All right. Um, Let me just go ahead and read this because I think it's worthwhile to state what I wrote here is that of course we're going to build up the demand side, the supply side of things, and to bring them together. Except now we are equipped, after we finish this class, you will be equipped with a much, much deeper understanding of why and how any market in the world, it doesn't have to be businesses, it doesn't have to be beer and tacos or fruit stands or the stock market or financial economics or anything like that. Anything in the world can be depicted, anything in the world, I should say, where you face scarcity and you're trying to maximize something can be depicted in this framework that we're trying to build up. All right. And the nuances, the subtleties, the little who has you might say market power, negotiating power, who has leverage versus who is more at the whim of the other side of the transaction. All of these little subtleties can be picked up and modeled with these graphs, with these equations. And so that's what we're trying to build up here. We're trying to give ourselves a taste of the framework for describing the world and describing the choices that people make in the world. All right. And like I said at the beginning of this talk, is that one thing that we haven't seen yet, not seen much of yet, is an actual demand function, right? An actual function for demand where you plug in a price, or if it was the inverse demand function, you would plug in a quantity and you would get some demand, all right? Um, of course, a reason for this is, as I said, we want to build up an intuition for these things, for one. And then for two, um, the demand function itself is just one small part of economics and just one of the things that an economist cares about when they're considering consumers, when they're considering the demand side of the problem. All right. So we want to build up this economic intuition first before we just go and mindlessly solve math problems. Because if there are math problems with no application to the real world or no economic intuition, then it's pretty pointless and you're just solving math problems for the fun of it, which is fun if you like that, but this is the science and we want to go deeper. All right. Now, with that in mind, as a preview, as a look ahead, suppose we wanted to get to this demand function, right? Well, so far we've been considering the consumer's problem with just two goods, right? It would be good X and good Y, beer and pizzas, everything that we've worked with so far, right? The way this works, the way this works, let me give a little idea here. From the consumer's problem, which we refer to as the utility maximization problem, from the utility maximization problem, you're going to get a solution. All right. You're going to get the optimal, as you've seen in your problem sets, you're going to get an optimal quantity demanded for good X and Y. All right. And so you'll see something like a quantity of good X demanded, which is a function of its price. You'll see a quantity of good Y demanded. Let me just fix this, which is also a function of its price. And then from here is where we do all the other economic analysis that we are used to. All right. So from the consumer's problem is where we get these demand functions. Now, one thing that we haven't done is we usually take prices as a given. We usually say that price of good X is this and price of good Y is this, and then we go and solve the consumer's problem. Then if we allow ourselves to generalize a bit more and we allow the prices to vary, this is what gives the demand curve. This is what gives the downward sloping demand curve that we saw in the last lecture. All right. So from the consumer's problem, we get the demand functions. And this is the essence of what we saw in our first micro class, the principles of micro class. Um, and then we kind of saw a sketch of it. I kind of gave you guys a graphical derivation for to give some intuition to why is the demand curve downward sloping and what do these functions actually look like. If we were to generalize a little bit more, we can from our I'm gonna add this and just in parentheses. From our two good utility maximization problem, from our two good consumers constrained consumers choice problem, we get something like this. We get a demand function for the good X or good Y, doesn't matter. But we get a demand function, which will be a function of the prices of two goods. All right. And I'm leaving this general on purpose. I'm leaving this general on purpose. So the demand function is a function of both the price of the itself, I'm sorry, the price of the good itself and the price of the alternative good. Now, if we make a simplifying assumption, and this is something we did in the last lecture, is like, okay, let the price of Y be fixed, and we only want to change the price of X. All right. This is what we saw in the last lecture. Um, and if we take whatever the demand function looks like and we isolate the how does the price of good Y into the function. If we hold that as fixed and we just hold that whatever it looks like in the function, we hold that as fixed, lump it into a constant, then we get something like this, which looks much more like a demand function that we saw in our principles of micro class, right? We see a quantity demanded is a function that depends inversely on the price of the good. So as the price goes up, quantity demanded goes down. And that's how we arrive at what we saw in principles of micro. We get that. Now, you might be thinking, well, in real life, we consider much more than two goods, right? And the answer is yes. The answer is yes. We just like the choice between two goods problem because it's easy to visualize graphically. And we want to start simple and then you can always generalize. This is something that you will see in econ, you will see this in mathematics, you will see this in your statistics class, in your CS classes, whatever major you're taking. You need to start with the simple case and then generalize. All right. Because if you can't solve the simple case, then you for sure won't be able to solve the general problem. And often the simple case can um, give some hints, give some intuition, give some ideas for how we can handle more complex problems. Now, for those of you that are more mathematically apt, or even just curious, this, what I'm about to say on the remainder of this page will not be on any assignment or anything for this class, but this is just a preview, a peek ahead. If everything so far is not satisfactory, or if you're just a little bit curious, have a taste for more. All right. So we've been working with just the two good problem, but you can generalize. You can extend this to be in I don't want to say infinite amount of goods, but you can generalize this to much more than two goods. All right. So if you guys have taken a linear algebra class or have worked with vectors and matrices at all before, then we can express demand functions in this way. All right, we can say that the quantity demanded of one good is a function of the price of all other goods that might be alternatives, all other things that might be alternatives to instead of buying good one, what is everything else that I could buy? All right. And all that changes. This is the beauty of linear algebra and why it's pretty helpful to take a linear algebra or matrix algebra class is that the function looks the exact same, except that this bold-faced P now represents a vector. Call it the price vector. All right. And the price vector contains the prices of all relevant things. All right. And so when we work with things in this way, in vector matrix notation, then we allow, we enable ourselves to consider more complicated um, and more, how should I say, encompassing scenarios. All right. So if this sounds interesting, then you are very well equipped. You should absolutely take some higher level econ classes. Take the 400 level econ classes or whatever other 300 level I think they are. I'm not exactly sure, but 400 levels for sure. It will consider just more problems, more general problems than a too good problem, or you might see more sophisticated setups. All right. But for now, don't worry about the complicated setup. I just wanted to give a little bit of a teaser of what we actually can do if we go a little bit further with this stuff. All right. But let me bring us back to where we are here in today in Econ 300 in this class is that we're just trying to get the fundamentals of this science, of the theory of this science. And how I've always seen it is that, especially with micro theory, that you can kind of treat this as like an algebra-based physics class. So I don't know if for those of you that have taken it, if you take physics in high school, even the AP physics, usually this is taught with like an algebra-based framework, and it is just to get the idea for how the mechanics of these things work, right? If you take more advanced class, you take university physics here, like the physics for science majors, physics for engineering majors, or physics for physics majors, right? You will use calculus and you will consider much more complicated mathematics, but the results are more or less the same. It's just that with the more complicated math, we get a better idea for how things are working under the hood. So you can treat this intermediate micro class like an algebra-based physics class. This gives you a great foundation for studying more advanced problems without needing to use all the advanced math. And then I have a little side note here that the lab equivalent would be an econometrics or a statistics component. But unfortunately, given our time constraint and given that this is just a theory class, we can't get into this right now. So if you want to see how to test these things, then take more econometrics classes, take statistics classes, specifically causal inference statistics classes, and that will give you some insight on how research and verifying these theories is actually done. But right now, we just care about the theory. All right. So with that preface in mind, I just wanted to kind of take stock of where we're at and where we're going. All right. So with that being said, today we're going to finish off the demand side of things. We're going to get the last pieces of consumer theory, of demand theory that we need in order to tackle all of the questions that might be asked in this class. So let's walk it back. Let's get some motivation. All right. So we want to consider two scenarios. All right. Suppose in 2020, this guy James has $100 to spend on his beer and tacos. And at the time, the price of a beer was $1 and the price of a taco was $4. Given these things and his preferences, his consumption, his optimal bundle was 60 tacos and one beer, or sorry, 10 beers, excuse me. And of course, we know that just to verify, just to verify that this is feasible, we know that 60 times $1 a piece plus 10 times $4 a piece equals 100. So for sure, he's using all of his money here. Now, consider inflation. All right, consider inflation. So 5 years later, his budget increases to $120. Now instead of $100, he's spending 120. And the price of a beer is still a buck, is still one buck per beer. All right, suppose. But now the price of a taco is $6 each. And suppose he keeps the same consumption combination. All right, keeps the same consumption bundle. If we do this, first we verify that, well, 60 times $1 plus 10 times $6. This does in fact equal $120. So he's still using all of his budget. So this is good. But my question to you is he better off or worse off? What do you think? Give you a few seconds. Sorry, take a minute or two to think about this question. Pause the video here and think about how you might use indifference curves And our budget line and indifference curves, this optimal, this constrained consumer's choice problem to answer this question. All right, give it a try and I'll review it and I will reveal the answer. All right. So let's see how we can think about this, how we can use a simple graphical um, derivation to answer this question. Maybe derivation is not the appropriate word, but you get what I mean. So let's label this. All right. So in 2020, we had tacos and beer, and then I want to keep this. I want to compare this for 2020. I want to compare this to what it looks like in 2025. Right, so let's get this right here, and then let's get this in 2025. All right. So how can we make a comparison like this using the things that we've learned so far? Well, we know that in 2020, his budget was $100. All right. And in tacos, in 2020, and I'm sorry, let's do, give me just a moment. Let us do, all right. I think it'll be helpful to write these things down just in case. So we had income was 100 bucks. We had that the price of a taco was equal to $4 here. Price of beer was equal to $1 here. All right. And then his bundle or basket was 60. We had 60 tacos and 10 beer. Okay. So let me flip these axes. Sorry about this. Let me just flip the labels on these axes. So we want tacos on the x-axis, and then let's do beers on the y-axis. All right, great. Very academic example that I love to work on. All right, clearly the Texan is showing through. Okay, so what would the budget line look like here? Well, if beers are a buck a piece and we have 100 bucks to spend, then clearly if we only bought beers, then we would have something like 100 is our maximum quantity of beers that we could purchase. Meanwhile, if tacos are 4 bucks a piece and we have 100 bucks to spend, then we have something like 25 right here. All right. And it doesn't need to be perfectly to scale. All I want to do is give this example to give some motivation for the things that we're considering. Okay. And we said the bundle now is 60, comma, comma, ah, excuse me. I I've 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 written something backwards. All right. Okay. Sorry about that. Um, I had incorrectly copied something down. I'm going to edit these things really quickly, and in the lecture notes, the actual file that gets posted, these typos will be corrected. So let me just make a quick adjustment. Okay. Sorry about that. I had to update my example from old lecture notes that I've been designing. So the original axes I had was correct, but let me show you what I had changed. Okay. And what will be changed in the final document. Uh, so the budget was fine, the price of beers was fine, and the price of tacos was fine. What I had reversed was in what you saw just a few moments ago, the first good was tacos and the second good was beer. All right. But how I meant for it to be was that the first good should be beer and the second good should be tacos. So the what I was drawing was correct. What I had typed up had a bit of a typo. All right. So just to recap, now that this is corrected, and again, sorry about that. Um, that In 2020, we have a budget of $100 to spend. Price of a beer is $1. The price of a taco is $4. And then suppose that the bundle he goes with is 60 beers and 10 tacos. All right. That's what he spends over 2020. Okay. And now this is why I was getting that I had beers on the x-axis and then I had tacos on the y-axis. And then this is what was changed up above was that this and this should instead be this and this. All right. Slight mistake. No worries. All right, no worries. All right. So what does this look like? Well, now we know how to find the intercepts. We know it just means you spend all your money there, and then you know you spend all your money there. And let me just, I do care a little bit about getting this um not doesn't have to be perfect, but I do want to illustrate something. All right. So this would have been the budget line. This is the budget line, right? We have, you could purchase all tacos, all beer, or some combination of the two. And we see that the combination of the two that James purchased in 2020 was 60, comma 10. So we had something like, maybe something like this, 60, comma 10. All right. Of course. So if this is what he purchased, then whatever his preferences are, he's going to have an indifference curve that's tangent. All right. He's going to have an indifference curve that's tangent to the budget line at this point. So his indifference curve, and then we know that here, slope of the IC is equal to the slope of the budget constraint of the budget line. In other words, the MRS is equal to the price ratio. All right. Now, in 2025, the price of beers stays the same. His income increases to 120. The price of beers stays the same at $1 a piece. But now the price of tacos is $6 each. Okay. And then suppose he still stays with this bundle with 60 beers and 10 tacos. So what does this look like here? Well, if he would spend, now we need to redraw the budget line. All right. Redraw the budget line. And we would see that we'd have a max of 120 beers now. But instead here, we would only have a max of 20 tacos now due to the price increase. All right. Due to the price increase, we can only purchase a max of 20. All right. And what do we see? Kind of, sort of. I think I drew it well enough to see this is here that because of this, that due to the price increase, that the budget line became flatter. All right. The budget line became flatter. You can kind of see this visually, that here it's a bit steeper than it is here. It's a bit flatter. And why is that? Because the price of the tacos went up, and so that brought the Y value down, the Y intercept down. All right. So if the budget line became flatter, that means that, remember, the price ratio is PX over PY. right? Whatever good on the price of the good on the x-axis divided by the good on the y-axis, price of the good on the y-axis decreased. All right. So the price ratio decreased. Now in 2020, don't know what happened there. In 2020, the MRS equaled the price ratio. In 2025, the MRS, since this price ratio decreased, now the MRS is greater than the price ratio. So what does this mean? Is first, is his old bundle optimal? No. So his old bundle is no longer optimal. All right. So his old bundle is no longer optimal. Just for completion's sake, let's go ahead and plot. Remember his old bundle was 60, comma 10. And I don't think I'm gonna be able to. Yeah, no, it's okay. So the old bundle is no longer optimal. We know that the MRS is now greater than the price ratio because the price ratio fell. So now the indifference curve has a steeper slope than the budget line. All right. And from our assignments, what do we know about that? All right. I tried to clean up the graph a little bit, maybe unsuccessfully, but what do we know about that? If the MRS is greater than the price ratio, that means the marginal utilities are out of whack. All right. This means that the old bundle is no longer optimal, and the optimal thing to do is, or we would put it as that it would be better to consume more of the good on the x-axis, right? It would be better to consume more of the good on the x-axis. In this case, that would be beers. And of course, consequently, that means less tacos. All right. So the purpose of this example, of this motivating example, is to show that when things change, if the prices of things change, then the consumer's optimal choice will also change. All right. This is kind of the focus of today's lecture is how do optimal choices change when other components of the problem change? All right. Exactly how much does the optimal change? Well, that is what we're going to learn. That is what we're going to look at. All right. Here, with this example, I didn't show anything about how the things changed. I just said that they should. All right. We know that this is the case, and so we know what should happen. All right. What we're going to see now is how can we differentiate, maybe I should say isolate, um, how what changes are coming from what parts of the problem. All right. Now, let's have a look and things will become clearer. So, what we're going to talk about today, more specifically with regards to how things are changing, is that we have uh, when your consumption bundle changes, you change a quantity demanded of something, right? So you have a change, you'll have a change in quantity demanded. I want a little thicker line. You have a change in quantity demanded. All right. The total change, call this the total effect. The total effect is the whole change. All right. What is the change that we see? We can break this down. We can break this down. Part of the change in our demand will come from, we want to break it into two components. We'll have one that's called the income effect and one that's called the substitution effect. All right. These are going to be the two components that we say comprise the change in demand that we see. All right. And we refer to these things as the income effect and the substitution effect. And one of the things that the motivating example was meant to show or remind us of was exactly what's in the box here, is that remember, when we change prices of things, this rotates the budget line. When we change the income of our consumer, how much they have to spend, this will shift the budget line. Keep these geometric interpretations in mind for this lecture. All right. And as I said, the change in quantity demanded, we decompose into two parts, the substitution effect and the income effect. All right. So for example, to illuminate this idea a little bit. So suppose you have a car. All right. Suppose you have a car and this is how you get around. This is how you get around town. This is how you get around Seattle. All right. Now, suppose the price of gasoline for taxes or environmental or even just supply and demand purposes goes up by 20%. How might your decision, your commuting decision, change? Well, one thing, one way in which that your decision might change, one thing that you might do, the first thing you might do is search for substitutes. All right, you might think of what are some alternative ways to get around, alternative ways of commuting. So you might search for substitutes. And this could be you could ride your bike, you could ride the bus, maybe you could buy an EV, all right, or take the train, all right. Any substitutes for transportation that you can think of, all right. Another thing you might do, another thing that might occur, that does occur, is that now gas has become more expensive. What this means is that suppose if I had $100 budget, well, now that money doesn't go as far, right? I don't get as much gas as I once was. And if I'm not searching for substitutes, then what happens to me, the consumer, is that my purchasing power has decreased. So purchasing, our purchasing power decreases. And what does this mean? Well, this might incline us to go out less. All right. So part of the effect, part of what might change when the price of gas goes up is that maybe we'll seek alternatives. We will look for substitutes, different forms of transportation. And another thing is that, well, our same income does not go as far, or the dollar doesn't stretch as far as it once did. So we might just choose to go out less because it's more expensive to go out using our car. This is the intuition for what is meant by the substitution effect and the income effect. The substitution effect is the change in demand that comes from this thing being more expensive. So we'll get some more utility from seeking an alternative. The income effect is the change in demand that comes from the fact that we're just relatively poorer. If our income didn't go up or it didn't match the price increase, then we're effectively poor, and so our purchasing power decreases. That is the intuition, all right? And this is what I have written here is that In the first case, right, driving has become more expensive, so we replace it with substitutes. All I want to know is that mathematically this changes, or not all I want to know. One thing I want to know is that mathematically this changes the price ratio. All right. Remember, gasoline went up, so the price ratio of the goods went up. And what did we see in the first example? Was that when the price ratio changes, this throws the MRS versus the price ratio. Now these things might not be equal. And so we're going to alter what we choose to do based on that. Additionally, purchasing power has decreased, so you feel poorer, um, and you decide to go out less. Another way to phrase this is that your real income has decreased. All right. So although income did not change at all, something with the budget line changed. All right. Our budget line, our dollar doesn't stretch as far. All right. So this changes what we refer to as real income, and we call this the income effect. All right. These two things, these two things, the substitution effect and the income effect, this these are the two components, the two pieces that make up the total change in demand. So let's color in these things a little bit. So I've given you the intuition, but how do we actually see what does this look like mathematically? What does this look like graphically? Let's consider this following example. All right. So take another example. Instead of beer and tacos, we're going to just work with X and Y. All right. So you suppose you have $40 to spend on goods X and good Y. And the price of good X is currently $2, whereas the price of good Y is currently $4. What I want us to do is draw a budget line for this. And suppose I'm going to just tell you that the optimal consumption bundle at this point is 14, comma 3. And label this as point A, bundle A. All right. So let's draw this scenario. All right. And what you've seen, you could draw it in the margin right here, but I've actually given us a graph on the next page. So what I'm going to do is I'm going to just let us do copy this and paste this here, just so we have that off to the side. All right. So if our income is $40 and the price of good X is $2, then go ahead and be even more precise. It's quantity of X is 20. We could purchase a max of 20. And quantity of Y is 10. Purchase a max of 10. This would generate a budget curve like this, budget constraint like this, which we want to call BC1. All right. So at BC1, we have that the optimal bundle is 14, comma 3. All right. So right here, 14, comma 3. All right. And this, we call this bundle A. Now, what happens next is that suppose the price of good X increases. So instead of $2, now good X is $4. Of course, we know that this will change the budget curve. All right. This will yield a new budget line, which I want us to draw and label this as budget BC2. So now I'm going to do this in blue. So BC2 is in blue. The y-intercept stays the same, but now the x-intercept moves. Let's do that. And then right there. All right. And then suppose we solved the consumer's problem and we found that the new optimal consumption is 3 comma 6. All right. So we have something like, all right, just suppose this is correct. All right, suppose this is maybe I drew it a little bit higher. Whatever. All right. 3 comma 6 is B. All right, I don't want to make the graph messy. Just know that B is 3 comma 6, whereas point A was 14 comma 3. All right. Now the question is, now the question is, we see that consumption changed. All right, quantity of good X changed. We went from, let's make a note of this over here, that originally the quantity demanded of good X was 14. Now quantity demanded of good X is equal to 3. So clearly the total effect, the total change in quantity demand, well, we went from 14 to 3. It's going to be a negative 11. All right. This is the change in quantity demand of good X. Then the question is how large was the income effect and how large is the substitute effect? Or rather, I want to know how large is the substitute effect? Let me write this a bit clearer. Could probably write this a bit bigger too. I also want to know what is the size, what is the magnitude of the income effect? All right. This is what we're going to see here. How to get this answer, how this is done, truthfully in higher level econ, maybe like an econ 400 class, you will see this breakdown with math, with calculus and maybe just general variables instead of specific numbers like this. But let me just give you the intuition. All right. So the idea is that, okay, well, here at point A, this is where we started, right? This is the original. And we had some indifference curve that we knew was tangent to our budget constraint at this point A. Right? This was IC1. How to visualize what happened is as follows. So the price of good X goes up, right? From $2 to $4. The first thing you want to do, the first thing to interpret what happens is that okay, the price of good X goes up. So pretend to isolate the effects from the substitution effect and the income effect, pretend that somebody gave you extra cash to keep you at the same utility. All right. So what I mean by that is that from A, we were consuming 14 and 3. This produced an indifference curve. All right. This was the highest, this indifference curve corresponded to the highest level of utility. Well, the price of goods of the good went up. That's for sure, right? That means that we had given, remember, the price ratio determines the slope of the budget constraint, whereas the actual income, the money you have to spend, determines whether it shifts left, sorry, left or right. But you get what I mean, all right? Left or right. All right. So the price ratio went up and we can't change that. But suppose somebody came through and gave you money to support the same level of utility. Graphically, what this would look like is that we would have a budget constraint, a budget line, a compensated budget line with the same slope as the blue line, but it would be shifted to the right because we were compensated. We have more cash to spend. All right. And what would this do? They give us just enough cash such that it keeps us at the same level of utility. So what this looks like is, let me see if I can. Yes, yes, yes. So what I want to, nice try, I guess. It's all good. Um, Let me see if I can do this. One more try, or else I'll just retry it. Ah, it's okay. All right, what this does, if we were to draw, there we go, a nice parallel line. Remember, increasing income just causes a parallel shift of the budget line. All right. So what this does is it shifts the budget line outward, and we find what is the new point. What is the new point at which this budget line is tangent to our indifference curve. All right. And let me just clean up this graph just a second. One second. Okay. I changed my graph a little bit, so just try and follow along with me. I want it to be a little bit accurate with the details just so it can match, it can corroborate with what I'm saying. So, as I said, suppose the price of good X increased. Now, of course, this means that this old bundle is no longer optimal, but what's going to happen? How will our optimal bundle change? Optimal consumption change. If somebody were to give you money to sustain the same level of utility, and this is one of the things I changed, I just flattened out the indifference curve a little bit. This point A corresponded to an indifference curve, IC1, all right? They're like, then suppose okay, well, suppose I wanted to stay at IC1. Then I would need to get more cash from somewhere, and suppose I got the more cash. So this causes a parallel shift of my budget line. What this does is I see that there is now a new tangency point. All right. I see that there is now a new tangency point that I'm going to just claim is at uh 8, comma 8. All right. And I want to call this tangency point, call this A prime. So A prime is right here. 8, comma 8 is where I would be at if I had the same amount. I'm sorry, 8, comma 8 is where I would be at if I wanted to have the same level of utility given these price changes, but supposing that I could afford it, like my budget increased as well. This part of it, this part of it, this change from A to A prime, this is the substitution effect. All right. From A to A prime is the substitution effect. It's the change in demand which keeps utility that is the same level of utility given the price change. So we see that um, from here, looking at X, or I should say the quantity demanded of X, we went from 14 to 8. Thus, we had a change in quantity demanded in X of -6. All right. So clearly, we can kind of tell that, okay, if the total effect was -11, then how large is the substitution effect? This is -6. Now let me complete the illustration, but it's not too hard to guess what will come here. All right. So now, instead of being compensated, um, instead of being compensated, I should say that whole compensated exercise to keep us at the same level of utility, this isolates the substitution effect. All right. And if we know what the substitution effect is, then this automatically gives us what the income effect is. So what I mean when I say that is that now I know that A prime from A to A prime represents the substitution effect. Then when I look at what does the consumer actually do, and they choose not A prime, but they choose B because nobody gave them any more cash. They have to work with the new budget. They got to do their whole new utility maximization problem. Then, of course, we will be on a lower indifference curve. Let me try and do it at roughly the same. That's pretty good. Something like that. Just so this will bring us to a lower indifference curve, all right, because our purchasing power decreased. We can't afford as much stuff. So our utility does go down because in reality, nobody's going to compensate us every time prices go up. And so the actual bundle that we end up at is B. Now, from A prime to B, that is the income effect. Going from A prime to B, that is the income effect. This is the part of the change in demand that is due to the decrease in purchasing power. So here we went from 8 to 3. The change in quantity demanded of X is equal to -5. Thus, this is how we isolate the substitution effect from the income effect. This is what is meant by these two things. This relationship right here. Remember, this is the total change in quantity demanded of X. This is due this is due to two things. It's the substitution effect. It's how do our marginal utilities change? And then we have the income effect is what is the change in demand due to change in purchasing power. This whole thing is referred to as the Slutsky equation. And some certain ambitious principles of micro classes will try to introduce this as in the first class, but I think that's a bit too much to try and introduce for just a principles level class. But now that we're here, now that we're a little bit more familiar with the consumer's problem and where do those bundles come from, now this is a better spot to introduce these things. So the total effect here, we saw that the total effect was -11. All right. Total effect was -11. And where did this come from? Well, we saw that the substitution effect contributed a -6, while the income effect contributed a -5. That's the intuition for what these things are and how we try to decompose the change in demand due to utility versus due to just a decrease in purchasing power. All right. Not decrease in utility, I should say, a change in marginal utilities. All right, let me be a little bit more specific. And then, yeah, so if you do take higher level econ classes, specifically higher level micro theory classes, then you'll see the Slutsky equation with more mathematics, with more calculus, with a little bit more analysis. But for now, this is enough. All I want you guys to understand at this point is that we have a total change in demand and it has two components, the substitution effect and the income effect. And that, the substitution effect, is what happens um, when the price ratio changes, and the income effect is what happens when our purchasing power decreases. All right. Very real world things, all right? Especially the purchasing power one. I feel like that one's pretty easy to imagine. Um, but this is just little bits of micro theory that enrich these models, allow us to answer a bit more targeted questions. All right. And if that was complicated, then go back and watch this section again. It's probably pretty helpful to see this derivation of this graph a couple of times, at least more than once. Um, yeah. Especially if you're an econ major and you do plan to like take like econ 400, this will be a very helpful reference for you. Or even if you do a master's in econ, if you decide that you like this stuff a lot, you end up taking micro theory class, refer back to this, and once you come to Slutsky equation, you will thank me. All right. Great. Great, great, great. Okay. Now, where are we going next? Well, let's relate this back to some things that we saw in the last lectures. All right. So remember, we were considering an increase in the price of a good. All right. Well, we remember in the last lectures, we referred to two types of goods. We had normal versus inferior goods. All right. And I gave the intuition that normal goods are your name brand goods. For normal goods, you purchased more as you got more income. I want to say, let's do reminder. Reminder that if income increases, then for normal goods, quantity demanded increases. For inferior goods, the quantity demanded decreases. Let me just this here, this here, and then right there, right there. All right. What does the substitution effect and what does the income effect look like for these types of goods? We can actually assign signs to them based on this without going through the mathematical analysis of breaking down. Um, Remember, normal goods and inferior goods had to do with elasticities, which had to do with derivatives. Um, to spare us that analysis, it's not so important right now. We just want to get these concepts right here down. So for a normal good, if the price of something goes up, then the substitution effect goes up. I'm sorry, when the price of a good goes up, then for a normal good, the substitution effect is negative and the income effect is negative, right? Our income went down, so we're gonna buy less of this stuff, right? We're probably gonna go to generics. And then clearly, if the price of something is, if something becomes more expensive, then I'm gonna go and buy less of the expensive thing and more of the less expensive thing. All right. So this means, intuitively, this means that the substitution effect for normal good is negative and the income effect is also negative. So clearly, the change in quantity demanded is going to be negative. It's going to be less than zero. All right. Whereas, whereas for an inferior good, yes, the price change is going to give us, it's going to mess with the price ratio. It's going to affect marginal utilities, and thus the substitution effect is still going to be negative. However, however, the income effect component, remember, income effect is the change in demand that occurs due to a decrease in purchasing power. Well, the inferior goods are your generics. And so your income effect will actually be positive. you will actually get a small component of your change in demand is going to increase. You're going to consume more generics. So the income effect component is going to be positive. So here, the change in quantity demanded, in general, it's still going to be that you will decrease your consumption. Why? Because for an inferior good, the substitution effect dominates the income effect. All right. So the substitution effect in magnitude is usually bigger than the income effect. Um, but it's just worth noting that this actually fits into our mathematical framework that the income effect for an inferior good is positive. All right. But the substitution effect dominates, and so usually you will still see a decrease in quantity demanded. Now, this is some parts that you probably haven't heard of yet. Maybe you have, maybe you haven't, but this is pretty interesting in economics. All right. There are two other subclasses of these goods, which are kind of an anomaly. There's not too many things that behave this way, but we do have it. There are research papers, empirical studies that show that these types of things exist, and I think they're pretty interesting. So I wanted to include them for you guys. We have this idea of Giffen goods and Veblen goods. All right. And they when I describe them to you, they're gonna seem different, or they're gonna seem similar, but they are different for key reasons. All right. So a Giffen good is a non-luxury inferior good. So we already lump it into the inferior goods category. One of the distinguishing features here is that not only is it an inferior good, but usually this we care about, we're studying Giffen goods in the context of low income agents, so low income people. The anomaly here is that the quantity demanded actually increases as price increases. So some intuition for this, and this comes straight from a study, Jensen and Miller 2007 NBER working paper, if you want to look it up. But the idea is this. These guys, they went and collected data on people living in rural China. And to simplify their food budget for the week, suppose they just spent money on rice and meat. Now, meat is more expensive, right? The protein, or even tofu, right? Whatever have you. The protein is always more expensive than rice. Rice is very, very cheap. So if, but one of the key things about rice, right? If your family consumes a lot of rice, then you know this. Rice is cheap. Rice is an easy way to get calories, right? So you tend, especially if you're low income, you're gonna buy a lot of rice. All right. This keeps your family full, fed, and happy. All right. Whereas your proteins at the store, whether it's beef, pork, chicken, whatever, or tofu, whatever have you, these are always going to be pricier. What they found is that even when the price of rice goes up, does this mean that they will buy more meats, that they will buy more protein? No, no. Intuitively, why? Is because even if the price of rice goes up, um, the rice will feed us for more and for longer than the equivalent amount of money spent on proteins, on meat would feed us. So although the price of rice went up, we still bought more rice because the income effect was very large. All right. The price of rice went up, and so this decreased our purchasing power. And with decreased purchasing power, we're not going to buy more protein. We're not going to buy more meat because that we don't get too many servings if we buy meat. Instead, we're still going to buy more rice. We're going to actually buy more rice. We're going to shift more of our budget towards that because our purchasing power decreased. We may as well opt for the things that feed us for longer even if it costs more money now. One result of this is you actually get an upward sloping demand curve. So it defies the standard law of demand. And for this reason. Now, it's a very particular scenario and it takes a very particular setting, But there are occasions where these mathematical theories that we presented to you, they can go funky, you know? Same reason that we invented dark matter as an explanation for some things in physics, right? Something something in our theory just wasn't lining up, so we have to alter our theory to accommodate it. So with Giffen goods, remember they are inferior goods. So here the substitution effect is still negative, but the income effect is positive. And now with Giffen goods, after a price increase, the change in quantity demanded is actually positive. It's actually positive. All right. Whereas above, it was negative. Above, it was negative because the substitution effect dominated the income effect. But when we're considering Giffen goods, we get a positive change in quantity demanded. Why? Because here, the income effect dominates the substitution effect. And by that, I mean it's greater in magnitude. So, although we had the substitution effect that was decreasing, it's gonna, messing with prices is gonna mess with price ratio. It's gonna mess with marginal utility equality. So that would decrease consumption, but the income effect is stronger. Remember, we're dealing with low income populations when we want to consider Giffen goods. So the income effect tends to be stronger, and we would consume more of this stuff. And in this case, the income effect is greater in magnitude than the substitution effect. Another one that I find is always very interesting. This was something I learned about in I took a history of economic thought course. And it really I found this very interesting. Is that we have these things called Veblen goods. All right. Veblen goods are normal goods, which are luxury goods. All right. So Giffen were inferior goods for very low income. Well, Veblen goods are the opposite. Veblen goods are luxury goods, and these are usually purchased by very high income people. All right. In here, with Veblen goods, we see that the quantity demanded increases as the price increases, but for a different reason. All right. The reason, the phrase that was coined was conspicuous consumption. And it was coined by this economist named Thorsten Veblen. Very interesting character. If you want to read more, he's a very interesting guy. Very interesting. You should read more about him. The idea, conspicuous consumption, right here. What this means, essentially, what this means essentially is that there are some things that are very, very high priced, these luxury items. We buy them because we see them as a status symbol. All right. This is clearly we see this in the real world, right? We buy these types of goods because we see them as a status symbol. If you have a very nice Mercedes, a very nice BMW, Range Rover, whatever have you, is this really giving you that much more utility than a Toyota, than a Hyundai, than a Ford? Maybe even have like a Ford Mustang, right? Something that's fast as well. But why would you opt for the Beamer? Why would you opt for the C-Class Benz? Why would you opt for, a nice car? It's because there's a certain part of people that they want to show others that they can afford things. They get some utility from the fact that others can see that they can afford nice things. So you buy them because of the status symbol. I have it right here. All nonetheless, still very relevant, right? So we get an increase. We see that quantity demanded increases, but for a different reason. All right. It's because we like, or in the case of Veblen goods, at least, it's because we like the fact that they're pricey, that these things are luxury. That on its own brings us utility. So we get this upward sloping demand curve. And additionally, now the fact that this thing becomes pricier Now our substitution effect is actually positive. It's actually positive. Whereas the income effect, truly, I have it on here as positive. I think that it could be positive or negative after I gave it more thought. But no matter what, in any case, we see that the quantity demanded after a price increase, we actually demand this thing more. We actually want more of this thing after the price increases. And why is that? Because of conspicuous consumption. Or we could also say that the substitution effect dominates the income effect here. Or both are positive. Let me clear that up a little bit. So that's how all of these ideas of substitution effect and income effect, that's how these things fit into the framework of the things that we've introduced so far. That's how they link back to these things. And we care about positives and negatives because we want to be able to test these things. We want to be able to test and determine via data, using data. And usually this involves data on people's consumption and how much they spend, how much money they spend on different things. Um, we want to get from our theory all of these signs and then see what the data tells us about whatever goods, whatever we're interested in studying. And again, both of these things yield an upward sloping demand curve, something that's counter to the law of demand that we're used to. So interesting things to think about, but I should restate that these are kind of anomalies. And for the most part, most goods are not going to be Giffen or Veblen. For the most part, most goods are going to be just your standard, your regular, all the other normal goods, all the other inferior goods. All right. And then I just thought to point out to remind that remember Giffen goes with inferior, whereas Veblen goes with normal goods. But they're just special types of these things. Now, right now, the last thing I want to talk about for this side, for this chapter, and the whole demand side of things, is actually a nice segue for what we're going to talk about next, which is the supply side of things. And that is the labor supply curve. All right. Because think about it, with demand so far, we've been thinking all about consumers. All right. Me, your buddy, anybody around you, all consumers or even households, right? Well, when it comes to the labor supply, when businesses are looking to hire workers, who is one of the inputs that they need is labor. All right. We will see this in the future, possibly even in the next lecture. But as a preview, for a firm, their output, and this is usually like a quantity, is a function of we usually just refer to as capital and labor. All right. K is capital, L is labor, clearly. But this L, this labor, where does labor come from? Who provides labor? It's us, it's the households. So in this framework, the roles have reversed. The roles have reversed. Who supplies the labor is the households. And so the labor supply comes from those who are typically thought of as consumers. All right. And we can derive a labor supply curve via this theory of the consumer that we've been working with so far. So let me show you. Let me show you how we get here. So to derive the supply curve of labor, it's easier to think not in terms of work hours, but in terms of non-work hours. All right. What do I mean by that? Well, each day you make a choice between working, you choose between working, which we say labor, and leisure, which is all the time spent not working. So we have labor and leisure. All right. In economic models, it's often easier to think of things in terms of leisure. Why is that? Because, write this down. Why leisure? Because the marginal utility of leisure is positive. All right. Everybody likes more time to chill. All right. And we want a positive marginal utility. So it's often easier mathematically to think of things in terms of leisure time because of this nice result right here, that the marginal utility then would be positive. Whereas the marginal utility of labor, of working, for most people, on average, this is negative. All right. On average, people don't get utility from working. They get utility from the stuff they buy with their money after working that they receive from working. But the work itself tends to not give people utility. You can accommodate this, and we just refer to it as disutility from labor, but it's easier to think of things in terms of leisure. Okay. So clearly, if we let H be the hours worked per day, and then the hours of leisure is N, then the number of hours you work is going to be capped at 24. And then it's minus whatever hours you spend not working. All right. Intuitive. We just needed to put some numbers to things. Now, we can determine a demand curve for leisure, but we need to define the price of leisure. All right. What is the price of 1 hour of not working? Well, it's going to be the wage that you would have earned from 1 hour of working. So 1 hour of chilling costs 1 hour of work time. All right. In other words, the price of leisure is foregone earnings. So the more money that you make from working, the more money an hour of chilling costs you, the more money an hour of leisure costs you. So if we gave this equation to represent income, where Y is total income, well, we have our hourly income. This is our labor income. We have our labor income plus our non-labor income. This is kind of a simplifying assumption, right? This is this is the money that your parents give you. This is residual money from like investments. This is what happens when that crazy crypto bet that you made pays off. All right, all of that is encapsulated by Y star. Uh, but to keep things simple, we just lump that all into a constant and denote it by Y star because what we really want to focus on is the labor part of it. So your income is the money you earn from working and the money you earn elsewhere. All right. If we simplify and say, okay, let this Y star equal 0, and then we substitute what we had above, then we come to this expression. All right. We get Y is equal to W times 24 minus N. All right. And if W is held constant, then this actually produces a budget line. All right. This actually produces a budget line. And I don't need to mark any numbers on the axes. Let's just put that this is, remember, when W is held constant, then let's put income Y on the Y-axis. And then let's put, we can do leisure hours on the X-axis. In on the X-axis. And this produces a budget line. This actually produces a budget line where if we have 24 hours of leisure, if we don't work at all, then how much income do we make? We make nothing. All right. And if we spend all of our time working, well then we make the most amount of money possible. In reverse, an alternative, this will become apparent in a second. You could also think as this as labor hours. Think of this as labor hours. H. But instead of 24, this would be a 0, and this would be 24. All right. Two ways to represent the same thing. All right. And then from here, now we have a budget line, and then then we could put this into our framework for the consumer that we're not going to do a mathematical example here, but I just want to say that from here, the consumer would solve their utility maximization problem by choosing the max hours of labor or leisure, whatever have you. Let's say lowercase l right here is leisure. They would max their utility from leisure, subject to their budget constraint. And then this would give us the optimal amount of income and free time that they would want. And you just call that E or E star. All right. This is how we can fit this into our consumers problem framework. All right. And then we can derive, as I've put here, the optimal amount of earnings and leisure, or earnings and work hours. Now, in this example, we held wage constant. All right. We held wage constant. We assumed that, okay, you you only got this one wage rate, and then you just choose how much you're going to work and how much you're going to earn. What if instead we held y constant? We said, okay, now suppose you're trying to earn the same amount of money regardless. What does it look like? How many hours of work or non-work will you choose if you're trying to earn the same amount of money, but just given these different wage levels? All right. Let me clarify this. All right. So if instead y is held constant, then from 1, and when I say from 1, I mean equation 1. If we hold this constant and we still assume this to be 0, so this is a constant, this is gone. Let's go ahead and write this here. So y equals w times h of, and there's nothing else. What we want to do is we want to get wage as a function of hours worked, because remember h is hours worked. So you'd see something like this, w equals y over h. And this would give us the labor supply curve. All right. And the labor supply curve looks a little something like this. Of course, it would be helpful to label axes. So let's say wage W, and this is hours of work H. And we see that um, we would see that. Let me erase that right now. Then this would give us, yeah, I see what I was. The book kind of spared some details, so just ignore what I had written right there. What we'd find is that we can, what do we get? Is we get something like an upward sloping labor supply curve. And what this represents is how many hours of work, let me write this down. How many hours of work would we choose? Like how much would we choose to work given these different like pay levels or these different wage levels? So the labor supply curve plots how many hours we decide to work given different wage levels. Now, the reason why I took pause for a second is because right here, as I've depicted it to you, is just an upward sloping curve. All right. One of the things is that this need not always be upward sloping. All right. And what do I mean by that? Well, an alternative, an alternative is that, and this is where it actually gets more realistic. Because what does a linear thing tell us? It tells us that if we get paid more, then we're always going to choose to work more. Now, is that realistic? Maybe not. One thing that we might see instead is that, sure, uh, if our wage is really low, then yeah, we'll start to work more. But it gets to a point where if we start to make a lot of money, then I'm going to decrease how much I work. I don't know about you guys, but what if I get so many raises, I'm okay with capping myself at a level of income that I'm willing to dial back my hours worked because I'm making good money. And so what we will see is that you can actually have this bending, this backward bending labor supply curve. All right. And so it need not always be upward sloping. All right. So let me come back to this. Let me come back to this. So keep that thought in your head, but just keep that thought in your head for now. If instead, now with those things in mind, if instead this was wage versus hours of work, let us instead look at or consider wage W against hours of leisure. And remember, our equation 2 gave us this right here. So with this, we see that we can also have the leisure demand curve. The leisure demand curve. Remember, the price of leisure is the wage that you could have earned. So this is your price, and this is your quantity. All right. And here is where we see the more typical downward sloping demand, except this is specifically the leisure demand curve. All right. In this formulation, we get a downward sloping demand curve. And why is that? It's because we can formulate the consumer's problem in terms of choosing how much they want to work. All right. That was the whole point of this right here. And from this same setup, in conjunction with what we saw in past lectures when we derived the downward sloping demand curve, we arrive at this leisure demand curve. Um, and it retains all of the properties of demand curves that we have been talking about thus far. All right. So this is kind of a taste, just a small taste of what a labor economist works with. All right. You can explore. I have to double check and see if UW offers a class like this, but at my undergrad institution, we offered a specific econ higher level elective called labor economics, where you looked at all sorts of these different issues with like how are different laborers, how do their demand curves and whatnot. How's the labor supply curve look like? And you will find that like different industries, different markets will have different looking demand and supply curves. Sometimes the workers have more negotiating power, more bargaining power, and this can affect what those curves look like and who has a say at the table, right? Whereas if you consider maybe more disposable positions, right, like one of the ways in which this country operates is that we often will employ immigrants. Specifically, I'm from the South, so it was a big industry is down there is agriculture industry. And a lot of the agricultural workers, a lot of our farm workers are immigrants, and they may not be citizens. And in those cases, those workers have less bargaining power. And so this will affect how their supply and their labor supply and labor demand curves look. All of these things are what a labor economist works with and is interested in. Now, I would love to go into more detail about this stuff, but given the time constraints of this class, given that it's only an 8-week summer session, plus like a week for the exams, one and one, I can't get it too much into detail. So what I'm going to leave you guys off with is just a little collection of theoretical and empirical facts about some of this labor economic stuff. All right. And some of it is what we saw right here. The labor supply curve can slope upwards, bend backwards, or do a combination of both, depending on the income elasticity of leisure. All right. How much does my quantity demanded of leisure change with respect to how much my income changes or my wage changes? All right. Both of these things we want to consider. All right. And realistically, theory predicts that at low incomes, leisure is an inferior good, meaning that at low income, if I'm a low income person and I'm earning more money, then I would demand less leisure. All right. If I'm starting at low income and I get a raise, I'm probably gonna work more because I was low income because I need more money. All right. I was down bad and now I have an opportunity to reverse that. Whereas at higher incomes, it's a normal good. All right. Leisure is a normal good. Meaning that if I'm already at high income and I get a raise, well, I'm probably gonna start booking more days off, not less. All right. Because I was already chilling. I was already comfortable. There's no reason that I would want to work more if I'm already at high income. Empirically, all right, what the data tells us is that the labor supply curve is relatively inelastic. All right, it's relatively vertical. This is a thing, if you take macroeconomics, turns out that the labor supply curve is a very important topic. Um, and the data finds that it's vertical. All right. And what this means that data suggests that if this is the labor supply, all right, what this means is that for the number of hours worked, um, this doesn't really change with income. This doesn't really change um, with how much you're getting paid. Generally, right? If we were to just assign a regular number, call it 8 hours, right? 8 hour workday. Generally, more for the most part, at least these studies that the textbook refers to, people are going to choose that same 8 hour number. On average, people will choose that 8 hour number regardless of how much they're getting paid. All right. So what does this mean? Well, for modeling purposes, this means that the supply of labor is fixed. It means that it's fixed, so you can't increase. Let me make this a bit clearer. You can't do much to increase uh how many hours one person will work. All right, they're gonna chill at that 8 hour mark, and that's what they're gonna be at. This will have implications for how firms choose how much to pay their workers. All right. Because if you're gonna work 8 hours regardless of whether I'm paying you the lowest amount or the highest amount of the salary range, then what are firms gonna do? They're probably gonna opt for that lowest amount. And if that range is big enough, then it might just be cheaper to hire two of you guys at the lowest amount than hire one really good guy at the highest amount. All right. It's something to consider from the firm's perspective. All right. Um, and with this data, this would imply that the income and substitution effects offset each other. So one might be negative, one might be positive, and they more or less cancel out. Um, but this is just one of the things that this micro theory, once we go out and estimate it in the real world, this better informs our model. So we go from theory to data, back to theory. All right. This is how we get better models. All right. And let me cut it right there. That's all I want to say about this labor stuff. Um, because as I said, I won't have too much, I won't have time, unfortunately, to get into more nuance about this, about labor supply and labor demand. But there's more information in that textbook, and I highly encourage you that if you find this stuff interesting, to take more econ classes, take higher level econ classes, and you will learn a lot of interesting, really very cool stuff about what do these things look like for different markets, different parts of the world even. Could be the same type of worker, but in different countries, could have different due to laws or social like culture norms. For one reason or another, same market, same type of worker could have different features if they're in different parts of the world. All right. This now concludes the demand side of things. Um, what we're going to be working on from here on out, not from here on out, but the next thing that we're going to start on with the next lecture is going to be the supply side of things. All right. What we've seen, what we've been working with in the past with this lecture and the three before it, were all of the consumer's problem, all of the demand side. How do we get the demand curve? Now we need to go to the other side of the table. The other side of the transaction is the firm's problem. All right. And what's key there is going to be profit maximization. So we're going to see how do firms maximize profit? How do we put this into a mathematical model? And how do we get the supply curves from what we saw in our principles of micro class? All right. So that's what's coming next. Let me know if you have any questions about this video, and I'll see you guys next time.